Hello and welcome to another yearly past paper session. This one is November 2023 and the year is the variant is 4.2. Let's start with the questions. The first one says a block of mass 15 kgs. So this says a block of mass 15 kgs slides down a line of greatest slope of an inclined plane. The top of the plane is at a vertical height of 1.6 meters. So 1.6 meters. The speed of the block at the top of the plane is 2. Speed of the block at the bottom of the plane is 4. Find the work done against the resistance to the motion. So I'm going to use the work energy principle. Work done by driving force, external driving force, equals to change in Ke plus change in P plus work done by resistance. Okay, so there is no external driving force coming down naturally, so I'm going to say 0. Then change in K is half m v square minus u square plus change in PE. So the change in PE is negative because the block is sliding down the plane. G and H. Okay. Work done by resistance is then unknown. So I get what, let's calculate. Okay, so 15 into 16 minus 4 divided by 2 is 90 minus 15 into 1.6, 1 to 10 to 40. 150 is work done by resistance. That's in joules. Okay, that's the first question. Moving on to the next one, it says the diagram shows a smooth ring R of mass m kg threaded on a light inextensible string. A horizontal force of magnitude 2 newtons acts on R. The ends of the strings are attached to fixed points A and B on a vertical wall. The part AR of the string makes an angle of 30 degrees. Okay. And the part BR makes an angle of 40 degrees with the vertical, and the string is taut. The ring is in equilibrium. Okay, so there's 10 m force here. There's a tension here. Let's resolve that. That's T cos 30 and T sine 30. There's a tension here as well. So that's T sine 40 and T cos 40. Okay. Um, it's an equilibrium, so up equals to down, left equals to right. Up is T cos 30, down is T cos 40 plus 10. Left equals to right. T sine 30, T sine 40 equals to 2. So T should equal 2 over sine 30 plus sine 40. Okay, so let's see if we get T correct. Then we will go on and calculate M sine 30 plus sine 40. That gives me 1.75 newtons, and plugging that here, T cos 30 minus T cos 40 equals to 10 m, and M is therefore T cos 30. So I'm going to use the exact value from my calculator and then try to work with that. I'm going to say that answer bracket cos 30 minus cos 40. Gives me 0.0175. Okay, that's question number two. And those are the two final answers. Let's move on to question number three. Okay, so question number three says a block of mass 10 kgs is at rest on a rough inclined plane at an angle of 30 degrees to the horizontal. A force of 120 newtons is applied to the block at an angle of 20 degrees above the line of greatest slope. There is a force resisting the motion of the block and 200 joules of work done against this force. Okay, so there's a force resisting the motion of the block and 200 joules of work is done against this force when the block has moved a distance of 5 meters up the plane from rest. Find the speed of the block when it has moved up the plane. So I think I'm going to use work done by driving force. I'm going to use the work energy principle. Okay, so the work done by resistance is 200. And I want to calculate the speed. Half m v square is the unknown. Uh, okay, so from rest, so 0 square, change in p is m, g it's gaining potential energy as well, and h has to be 5, so 5 sine theta, 5 sine theta. What is the work done by the driving force? It's 120 cos 20 into the distance that it's traveling, so it's 5 meters up the plane. Okay, let's calculate for V. I know I can put this entire thing on a calculator in one go and give you a final answer, and I'm probably going to do that. Use my calculator to open up the solver and solve that equation. 120 cos 20 to 5 equals to 5x squared plus 500 sine 30 plus 200, and which one is going to be? I'm getting V equals to 4.77 on my calculator. Okay, and that is the correct answer. Let's move on to the next question. It says a particle of mass 0.2 kgs lies at rest on a rough horizontal plane. Okay, um, a horizontal force of 1.2 newtons is applied to P. Given that P is in limiting equilibrium, find the coefficient of friction between P and the plane. So mu into R, that's 2, that's R. So R equals to 2 and 1.2 equals to mu R. 1.2 equals to mu times 2 and mu equals to 1.2 over 2. Okay, that should give you the correct answer, hopefully. That's 0.6. Given instead that the coefficient of friction between P and the plane is 0.3. Find the distance traveled by P in the third second of its motion. Okay, so that's important. Let's find out how much distance it travels in the third second of its motion. So this is 2, this is again 2, that's the normal reaction. and there's a driving force of 1.2. So 1.2 minus zero point 0.3 into 2 equals to ma. That's going to tell me my acceleration. That was 0.6. 0.6 divided by 0.2 gives you 3. Okay, so acceleration is 3, the starting speed is 0, acceleration is 3, find the distance that it travels in the third second of its motion. So what I'm going to do is I'm going to find both the distance at t equals to 2 and then t equals to 3, and I'm going to subtract that distance. So s equals to ut plus half a t squared. Let's see what that gives me. That gives me, I think, 6. And then s equals to ut plus half a t squared. So 27 over 2 gives you 13.5. So the distance traveled in the third second is 13.5 minus 6. That should give you 7.5, and yes, that's the correct answer. So move on to question number 5. It says a particle of mass 0.5 kgs is projected vertically upwards from horizontal ground with speed of 25. Find the speed of A when it reaches a height of 20 meters above the ground. The acceleration has to be minus 10. So I'm asking you to find the speed of the particle. So v square equals to u square plus 2as. V square is unknown. So 25 squared plus 2 times minus 10 times 20. 40 and so v equals to 15. Okay. So 15 meter per second is the correct answer. When A reaches a height of 20 meters, it collides with its particle B of mass 0.3 kg, which is moving downwards in the same vertical line. So this is a question on momentum. Um, okay. So S is 20. Okay. So this is question about momentum. Momentum before equals to momentum after. That's conservation of momentum, which is moving downwards A with a speed of 32.5 in the collision between the two particles B is brought to instantaneous rest. So after, let's first talk about before. A has a mass of 0.5 and it's traveling with a speed of 15 when it collides, and B is traveling in the opposite direction. So the speed is minus 32.5. Then in the collision between the two, particle B is brought to instantaneous rest. Show that the velocity of A immediately after the collision is this. So let's try to do that. 0.5 into 15 minus 0.3 into 32.5 gives you minus 2.25 equals to 0.5 v divided by 0.5. So v equals to minus 4.5. Since upward was positive, downwards is negative, and that's where A is moving after the collision. Find the time interval between A and B reaching the ground. So B has come to instantaneous rest. It's going to start moving downwards with an acceleration of 10. Since this is 20 meters above the ground, that's what I'm going to try to calculate. I want to find the time. So how long does it take B to reach the ground? I'm going to say S equals to ut plus half at square. 20 equals to 0 t plus half times 10 times t squared. So that gives me t equals to 2. Okay, then for A, it started moving with the speed of 4.5. It should have an acceleration of 10 as well. It's going to move a distance of 20 meters as well, and the time is unknown. So let's do that then. S equals to ut plus half at square. So that's a quadratic equation that I need to solve. I'm going to write minus b plus minus root of b square minus 4ac over 2a. 1.6 and minus 2.5, so 1.6 should be the correct answer. What's the difference between the two times? I'm going to say that the difference in time is 2 minus 1.6, so that's a distance time difference of 0.4 seconds. Okay, moving on. Question number 6, and we have 7 after that. Okay. A railway engine of mass 120,000 is towing a coach of mass 60,000 up a line straight track inclined at an angle of the alpha degrees to the horizontal. So 120,000, 60,000. Where sine alpha equals to 0.02. Okay. There's a light rigid coupling parallel to the track connecting the engine and the coach. So it has a tension. The driving force produced by the engine is 125,000 newtons. And there's a constant resistances of 22,000 on the engine and 13,000 on the coach. So 22,000 on the engine and 13,000 on the coach. Find the acceleration of the engine and the tension in the string. So when I talk about the engine, for the engine, what is happening is it's being driven forward by 125,000. There is a constant resistance of 22,000, and then there's also a weight component, which is 120,000 times g times sine alpha. Okay, so 120,000 times g times sine alpha equals to ma, and the tension as well, sorry, minus the tension. The tension is pulling it back, equals to ma, 120,000 a. Then for the coach, the tension is pulling it forward. It's being resisted by 13,000 as the tension, and then 600,000 sine alpha equals to 60,000 A. The tensions will cancel out, and I'm left with all this calculation. Let's calculate this. Um, I get 125,000 minus 22,000. So that's 90,000 minus 1,200,000 plus 600,000. Sine alpha was 0.02, so into 0.02 minus 36,000 equals to 180,000 A. Very big numbers, you could ignore the thousands and then work with it as well. but I've already written it down, so I'm just going to stick to that. So the acceleration comes out as 0.3. That's the correct answer. I also want the tension, so I'm going to write this again. T minus 13,000 minus 600,000 into 0.2, 0.02, 60,000 into 0.3. So 60,000 into zero point 0.3 plus 600,000 to 0.02 plus 13,000. Okay. At an instant when the engine is traveling at 30, it comes to a section of track inclined upwards at an angle of beta to the horizontal. The power produced by the engine is now 4,500,000 watts, and as a result, the engine maintains a constant speed, so the acceleration becomes zero. Assuming that the resistance forces remain unchanged, find the value of B. So the angle has become different. So the driving force is now 4,500,000 divided by the velocity. Power equals to force into velocity. What is the resistance? The resistances are unchanged. Uh, so what were the resistances? 20,000, 22,000 for the engine, and then 1200,000 sine beta should now be my angle, and I've done acceleration equals to zero because the question says there is constant speed. That was for the engine. For the coach as well, what happens is the driving force is T. Okay, and I will then have the resisting forces, that was 13,000, and then 600,000 sine beta. Again, equals to 60,000 into 0. The tensions cancel out. So I have 1500,000. Let's calculate all of this. Um, that's 4,500. 450,000 divided by 3 is 150,000. 150,000 minus 22,000 minus 13,000 gives me 115,000 minus 1800,000 sine beta equals to 0. Solving for sine beta, so beta equals to sine inverse of 115,000 divided by 1800,000. Doing this gives me 3.663 degrees, so B is 3.7 degrees because answers in degrees are correct to one decimal place. Moving on to the last question for this exam, it says a particle x travels in a straight line. The velocity of x at time t seconds after leaving fixed point O is denoted by v, where v equals to that. The acceleration of x is 0 and t equals to p and t equals to q, where p is less than q. Find the value of p and the value of q. Okay, so that's the velocity. The acceleration of x is 0. So for acceleration, you have to differentiate. So acceleration becomes minus 0.3 t squared plus 3.6 t minus 6. Okay, The acceleration is 0, so at these 2 points. So what I basically have to solve is a quadratic equation. I'm going to use the quadratic formula minus b plus minus root of b square minus 4ac over 2a. Okay, so putting that on my calculator gives me 10 and 2. So p is less than q, so this is p and this is q. Then says that it is given that the velocity of x is 0 at t equals to 14. Okay, find the velocities of x at t equals to p and t equals to q, and hence sketch a velocity time graph for the motion of x from t0 to t15. Okay, so the velocity function is given by minus 0.1 t cube plus 1.8 t squared. It's a cubic function, and what I've basically calculated is two turning points of the function, 6t plus 5.6. Okay, so at for the first turning point, I'm finding out the velocity and then I'm going to sketch a graph. There is space here. Okay, so I know that at t equals to 0, the graph is at 5.6. That's the y-intercept of the graph. So I'm getting minus 12 out of this. I hope that's the correct number. Just checking to make sure. Minus 0.1 into 2, 1.8 into 4, minus 6 into 2, not 4. Oh, so that's 0. So v equals to minus 0.1, 8 cube plus 1.8, 8 square minus 6 times 8 plus 5.6. Should be 2 here. Okay, so I am going to get 25.6 out of this. So what will the graph look like? Let's draw that. I want to start with 5.6 just and go up to 25.6. So I'm going to make this 5.6 is approximately here. What happens is the graph goes 2, 4, 6, sorry, 6, 8, 10, 12, 14, and 16. Okay, so the graph goes like this first, and then for the next part of the journey, it climbs up to 2, 4, 6, 8, 10, and then it goes somewhere up here. Okay, and it curves again, and then at 14 it's back down to 0, because that's what the question is telling me. And at 15, where does it land? I will have to find the speed at 15 as well. So it says from 0 to 15, so at 14 it's at 0. At 15 I could find out the exact value like I did for the rest of it, but it's going to be a pretty large value, I think. 15 squared, 15 cubed, then 15 squared, and then 15 itself. It's giving me, I think, 16.9. So it's way down there, 15 and minus somewhere down here. Okay, so that's the progression of that's the VT graph that I'm looking for. 5, 10, 15, 20, 25. Should number that as well. Okay, find the distance traveled by x between t0 and t15. Now remember that whenever you are integrating, it's important to realize that you have to integrate wherever it turns, and if it goes below the graph, then you have to make sure that the negative turns into a positive as well. So I'm going to integrate from 0 to 2. First, what is my expression for integration? I'm going to use this expression that I have for velocity, t cube plus 1.8 t square minus 6t plus 5.6. So I just have to keep changing the limits for my question. First, I'm going to integrate. This becomes power 4 divided by 4, 1.8 t cubed divided by 3, 6t squared divided by 2. Okay, so first I'm going to go from 0 to 2. Okay, and then I will have the same expression for 2 to 14. I could have done 2 to 14 directly as well, because the graph is not changing. The graph is not going into a negative there. This last one will be a little tricky. It is going to be from 14 to 15, and it is going to be a negative answer. So I'm going to make sure that I turn it into a positive one then. Okay, so I am going to put this on my calculator. I know that I need to put the upper limit as 2 and the lower limit as 0. I'm just going to use my calculator directly to speed up my calculations right now. I know that I still have to, on the exam, I have to make sure that I show them limits being plugged in. But right now I'm doing this directly to come up with the final answer. I have 2 and I have 0. So this is coming out as 132 over 25, and I have 14 and 2. I don't know why this is coming out as a negative number. Have I typed something incorrectly? Okay, that also wasn't right because I've typed it incorrectly. I haven't written an X. Yep. So 18 over 5, 864 over 5, and then from 14 to 15. This is minus 321 over 40. That is what I expected, but I want the total distance traveled, so I'm going to say 18 over 5. Let's say total distance traveled. Yes, it says total distance traveled plus 864 over 5 plus 321 over 40. So 18 over 5 plus 864 over 5 again plus 321 over 40. Okay, let's put that into a decimal. It says 184.425. Let's check if that's the correct answer. I'm not sure if I calculated correctly, but yes, that's the correct answer. So 184.425. That brings us to the end of this exam. I'll be back with another exam in the next video. Thank you for watching.